Hello, I'm Floris, and I'm going to talk about ES6 Ghosts. Well, it's about some of the features of ECMAScript 6, which is the next version of JavaScript. So I would like to start with a little bit of history. JavaScript started in Mountain View, California, where there was a company around 20 years ago, Netscape, which had the Netscape Navigator, one of the first browsers, and they decided in their second version of the browser to include the lightweight scripting language inside the browser. Initially they thought about putting Scheme, which was a dialect of Lisp developed at MIT, inside the browser. However, they decided that they should create a new language, which at that time was called Mocha, and they hired this guy, Brendan Nates, in order to create it. So, despite that a programming language would take many months of designing and implementing, since they had to release their new version, the Netscape Navigator 2, Brendan wrote JavaScript in 2 weeks. So after that time, JavaScript was ready as a beta version, and since it was developed in so little time, there were some problems with JavaScript, which, as you can see here, for example, if you add an empty array and an object, you get an object. However, if you add an empty object and an array, you get 0, which makes no sense at all. So, after that, they decided to standardize JavaScript. They called that standard, that spec, ECMAScript. And there was ECMAScript 1, 2, 3. At 4, they failed reaching the consensus, so then there was 5. And now we are at ECMAScript 6, which essentially aims to solve all these problems, though it can't solve them because that would break a lot of applications, so they just abstract them away. They try to do that at least. In this talk, I would like to talk about some of the features of ES6. There are many, so a single talk would not be able to cover them all. And I would like to start with let and const keywords, which are essentially block scoped variable declarations. So in order to understand that, we can see how variables work in C and most of the languages. And how is this done is that any variable that is declared, it lives inside the scope. A scope is declared with curly braces. So Y here lives inside the highlighted area. If you try to access it outside of this, then you get an error because it is not declared outside of that scope. However, in JavaScript, variables have function scope, which means that if a variable is declared inside the function, then it lives in all of that function, independent of in which block it was declared. However, if you try to access it outside of the function, then you get an error. So what they are trying to do with let is to create a keyword where you can declare variables which are block scoped. So even though if we had used var here, there would be no problem in this line. Using let, you get an error because, no, not this, here. Using let, you get an error because y was declared inside this block, so accessing it outside results in an error. Also there's const, which essentially declares immutable variables, aka constants, which is very simple. They are also block scoped. However, only the variable binding is immutable in const, not the content, which means that if you declare a const which has content like an object, then creating a new value and a new key and a new value, like here or here, would result in no problem. However, if you try to essentially wholly redeclare a new object, then you get a type error. This essentially tries to adhere to the principles of programming that a variable should live in the most succinct
place it was declared.
Yes. So the next feature I'm going to talk about is arrow functions. And arrow functions are essentially succinct syntax for anonymous functions. However, they are also, the difference is that they are lexical scoped, and we are going to find out what this means. So I'm going to start with the syntax. Here, using map, if you wanted to create a variable, an anonymous function passed into map, you would do something like this. Using arrow notation, you can have one variable without even using parentheses, and then whatever follows it is being returned. However, you can have more than one parameter, which means that you have to use parentheses, and also the arrow function must be followed by a block. So if you have a block, then you have to return what you want to have as a result. Another problem this arrow function solves is concerned with the notion of classes. So, assuming we have here a person which has an attribute age, and then we have a grow up function inside a set interval in order to increase age by 1 every second. Since we use the function declaration, accessing inside here this, had we written this.age, then this would show to a new context which would exist only in that function. However, we want to access age which is declared in this function. In order to do this, we create a new variable self and then access it through it. However, using arrow functions, we can have lexical scope, which means that this inside here is the context, the person context this, not a new this that we don't want to do anything with it. So that's another win here, because essentially we do what we want in using simpler syntax. So another feature. Thank you. Another feature of ES6 is the class keyword, which is essentially syntactic sugar. That's why I have the cake here. And what this does is creating inheritance, namely pseudo-classical inheritance, which this is what we have in JavaScript, in a simpler way. So if we wanted to do pseudo-classical inheritance in ES5, we would do it like this. We would create a function, and then we would have the objects, and we would add to the prototype object the function, the method we want, so as any new object created from this constructor would have increment age on it. Using class and syntactic sugar, we can have a syntax like this, which creates an object, which is also the class person. We have the constructor declared with the constructor keyword, and then any method exists like this, simple, inside the object of person. It's simpler, more readable, that's why they added it. Also, if we want to do subclasses using with ES5, we would do it like this, using call, and we would pass the prototypes in this way. However, using class and the extends keyword, we can do it like this. If, again, simpler, more readable. So, going to the next feature is Destructuring assignment. This is a feature definitely existing in Python. I believe they have taken many things from Python in ES6, but I don't know what the other languages implement destructuring. So what this does, it essentially destructures, for example, an array. Here we can do something like this, which means that A will take the first value here, and B will take the second. Also, it could be another variable here. Again, the same thing. The mapping happens one by one. Also, we can do it. Also, the spread operator is these three dots, which means that by doing this, we can have A, which maps onto 1, B maps to 2, and then all the rest values of the array on the right map to the rest array, which is automatically created, and then console logging the rest, we get that array. The same thing can be done with objects, and essentially this syntax right here, I don't know why the highlighting broke, this syntax right here is how you import modules in ES6, though I'm not gonna cover modules in my presentation. But using this, you can import a key of an object without importing the whole object. That's very cool. Of course, we can have a function which returns the array, and also we can do something like this, where in the second place there is no variable, and A is mapped to 1, nothing is mapped to 2, and C is mapped to 3. Another feature of ES6, also existing in Python, is default parameters. When we did, if we wanted to do default parameters in ES5, we would do it like this, which means that the caller of add two numbers doesn't provide any value for x and y, so they get an undefined value. And essentially, in this line right here, undefined evaluates to false. So after that OR, 0 is passed on to x. Using ES6, we can do it like this: cleaner, more succinct, better. There's nothing more into it, just that. Also, we have named parameters. The difference from the simple unnamed parameters is that you can pass the parameters without caring about their order, which means that you can do something like this. You pass an object, and even if there was width before height, it wouldn't matter, because you just pass an object, and inside there the key is height and width. This is like how jQuery does its options parameter, which we would do it in ES5 like this. And then we have REST parameters in ES6, which essentially uses the spread operator in here. And the difference from the arguments variable that we had in ES5 is that although arguments is not a fully-fledged array, args here is a fully-fledged array, and we can do what we can do with arrays in JavaScript. That's pretty good, because there is nearly no reason for arguments not be a full-fledged array. Also, we can use that syntax let off, which is a generator inspired one, and which passes on to the next chapter, generators. Again, this thing exists in Python. I don't know if they took it from there, but it's a very cool feature. So, generators are posable functions, which means that in a regular function you would return a value, and then that function would be done. However, using a generator function, you can return a value and then come back at that point that you stopped and continue the execution of that function until the end. So, in the simplest form, it would be something like this. You create a generator, and then using the next method, you get the next value which is being yielded. So, first is being yielded 1, which is essentially yield means return, and also relinquish control. So 1 is returned, and also you get done, which is false. Using again next, you get 2, which means this line is being run. Again 3, 4, and when you call next, and there is no yield to follow, then you get no value, and the done boolean evaluates to true. Also, that doesn't mean that you have to end it sometime. You can have an infinite generator, something we can see here, and that's perfectly valid. You just keep getting new numbers until forever. For example, let's see Fibonacci using generators. That's an interesting syntax, because here we can see that we can assign yield to a new variable, and this thing happens right here. You pass a parameter in the next method, and that parameter can be accessed in this syntax. So we can say that just give me the next value until here, and then we say that you know what, just reset it. It's being reset, the initial properties return to their initial value, and then we can start getting the next value from here on. So that's a very cool syntax. You can do something like this. And also using combining both destructuring and generators, you can see that Fibonacci becomes essentially 4 lines smaller. Destructuring is being used here, here, and here. Prev is mapped to 0 and current to 1. And also, you can use that with the new for-off, which is what I talked about in the last section. And essentially, for-off can run a generator, and then you can get you can log that, and of course break it when you're done. And also, you can run a generator using the spread operator, which is pretty cool. Though here I changed the implementation, I found that example SEs, and I changed the implementation so as you can pass an argument inside Fibonacci, so as the first 10 array can have a stop. Otherwise, the generator would be infinite, so it wouldn't know when to stop, and the destructuring couldn't be done. So what's interesting here is that we can see where this has applications. And this is from the Koa.js library, which is a web framework. And we can see here a middleware. Koa uses generators. Here what is done is that this is a middleware. So Koa is like Express, so you pass a function into the use. Start variable is created. Then you relinquish control using the yield. You go to the next middleware, and then you can call that again, which at that time there has been a new date. So you calculate the difference, and then you can add the header at your request, which shows the X response time, which is very nice. Since also you should know that Koa uses this object in order for the request. This is the request that will be returned. So I have talked about these features, which are almost the half of what ES6 is. There are more features. Promises are very important. We use them even though there wouldn't be we wouldn't use ES6, but we would use promises. I didn't cover them, although they are very important. It will require a whole new talk. Also modules which are very Python-like again. We have again string templates, which are also multi-line string. Sets and maps, which I think are very much like Java's sets and maps. Also we have symbols, of which part are iterators, and then we have reflection. And I believe also proxies may be inside ES6. I just learned that from Donis. I thought they would be in ES5, in ES7. So, any questions? I talked really good, I think. Nothing? Okay.
Right.
Thank you.
Thank you very much.